Let's discuss a question. This is a question on fatigue. You have a machine member where the axial load you vary from 80 to minus 40. So 80 to minus 40 is something which you're varying and it is going like this. So this is 80, okay, and this is minus 40. So the average load is 80 sigma 1 plus sigma 2 by 2. So average is 20. So somewhere here there is the average, and the variable, which is the amplitude, is basically the max minus the average. Or you can do P1 minus of P2 by 2. That is also okay. So 80 minus of minus 40 by 2. Or the max minus the average. That is also okay. So 60, 20 and 60 kilonewtons. And now let's get the average stresses. The average stress, because for fatigue you need both. So the mean stress or the average stress, mean stress or the average stress is 20. That is the average load by area, which is pi by 4 d square. So average is 20 kilonewtons 10 power 3 by average pi by 4 d square, which is 18 mm square. So this value comes about 78.6 MPa, and the variable stress is P average by pi by 2. So variable is, you take the variable component of the load and pi by d square. The variable component of the load is 60 kilonewtons by pi by 4 d square, which is 18 square. So 3 times of what you get there. So 235.6 MPa. So 235.8, in fact, you take the 3 times, you get this. Now Soderberg criteria basically says that mean stress by UTS. In fact, the yield stress is something which you have to use. Okay, the yield stress is not given, so we assume that, again, something, actually the Soderberg you have to use yield strength, and for Goodman you have to use ultimate strength, but again yield strength is not given, so we assume that ultimate and yield are very close. Okay, so that is one assumption. Sigma mean by sigma yield plus sigma variable by your endurance, that has to be 1 by FOS. So FOS is something which we need to find out. The mean is 78.6, yield is not given, but we assume that it is equal to the ultimate 591. Okay, and this is endurance is given as 542 and the variable is 235.8. so this value comes about is equal to 1 by FOS. The FOS value